This part of the tutorial we're actually going to model a multipath channel and also go ahead and re-add the add noise block in order to model noise, and by increasing the noise variance we're simulating decreasing signal noise ratio. So let's go ahead and open up tutorial number 3 as we had before, and what we're going to do is increase the working area, the workspace, by just dragging it out. We're going to move these two blocks all the way to the right here, create space in order to add a channel. So we go back to manipulate, select the blocks, and of course using the convenient tool, move them to the right. Go ahead and save this as tutorial number 4, and we're going to illustrate how to create actually a multipath channel in this area right here, and then later we're going to convert that to a hierarchical block. First thing we're going to do is actually disconnect this connection conveniently. We're going to move this block a little bit to the left, also move the filter, Nyquist filter, to the left. This will create some area where we can create a multipath channel model. The way we're going to do that is to model the channel as multipath using delays and gains. First thing we're going to do is add a delay block. I can just type in the name delay, and of course you'd like to move this out of the way and place it right over here. This is going to be a bulk delay. Next step is to add what you call a node block. Node block basically takes its samples at the input and forks them out to other blocks, and you'll notice that it'll actually grow. The next step is to add a gain block to the top. We're going to add another gain block right at the bottom here, and let's just move that slightly to the right. And we're going to connect the node block to these gain blocks, but at the bottom we're going to add another delay to model multipath. Let's put that right over here. Okay, now we're ready to connect up the blocks, and to connect it's very simple. Just select the block you want to connect from, select connect output, click on the destination block. Again, connect output, destination block. Select the block, connect output, connect it to the gain, select block, connect to the output, and you'll notice that for the node block it automatically grows, indicating how many connections are connected to it. Basically, the node block takes input samples from the input and copies those to both outputs, so both of these gain blocks are getting the same stream of samples. Now let's go ahead and connect the gain block to the delay block, and now we have to add the two multipaths together. So let's go ahead and create an add block right over here, and we're going to connect these two blocks to the add block, and of course they're going to be added, and the result is going to be a multipath model. Let's go ahead and connect the add block to the receive square root Nyquist filter. Okay, now we have a block diagram. It's a good idea to go ahead and save this. Let's go ahead and save this block diagram. We can just click on the save icon right here. And one thing we want to notice is that we have some area here which we're going to actually add an add noise block later. Let's go ahead and run a simulation. By default the gains are equal to 1, so let's go ahead and check this out. The gain here is equal to 1. We don't want any multipath at this time, so we're going to set the gain for the multipath to 0, and the delay here by default is 1, and that's just the bulk delay of the channel. We can just leave that, and let's go ahead and run a simulation. You'll notice that the eye diagram, there is no multipath distortion because we did set the gain here actually to 0. Let's go here and model our multipath setup. We're going to have a gain at the forward path of 1. That's the main impulse, the main signal getting through. We're going to have a gain here of 0.4, modeling the multipath, and the multipath delay we're going to change to 4 from 1. So let's go ahead and make that 4 from 1. and the multipaths are added up. So this is basically the main impulse being the main path, the main ray getting through, plus a delayed ray, say bouncing off of ground or some point, reflection point, barn maybe, and adding up with the main path, creating multipath. Now let's go ahead and run the simulation, and you'll see that the eye diagram has become obviously distorted due to the multipath. Let's go ahead and remove the multipath by making its gain equal to 0, as if there was no multipath. Run the simulation again. You'll see, of course, we got a open eye. Let's compare the two. And this is with multipath, and this is without multipath. Now, let's go back, add the gain 0.4, adding in that multipath. Of course, run the simulation again where we get the distortion. And let's go ahead and change the delay of the path. So if we decrease the delay, say to 1, then the delay dispersion has actually decreased. We would expect to have less intersymbol interference. So let's go ahead and run the simulation, and that's in fact what we get. So if in fact we do decrease the delay, then we have decreased the delay dispersion and therefore the intersymbol interference. All right, let's go back, increase the delay dispersion. Let's go ahead and make that 6. Of course, run the simulation again, and you'll see we get quite a bit of distortion due to intersymbol interference. So what we've done is demonstrated how you can actually create a simple multipath based on basic building blocks, in this case the node block, delay block, and the gain block, and investigate how multipath affects, of course, the eye diagram. Now much later we would have tutorials that describe how to remove the effect of multipath using decision feedback equalizers at the receiver. For now, we've just modeled a multipath, and the next step is to actually model this whole multipath environment as a hierarchical block where we can reuse it in other block diagram simulations. This concludes this part of the tutorial.